Let's discuss solve problem 5 on singly linked list. Let P be a singly linked list. Let Q be the pointer to an intermediate node X in the list. What is the worst case time complexity of the best known algorithm to delete the node X from the list? These are the options available in front of you, and this question has been asked in GATE IT 2004. I would encourage you to pause the video for a while and try to answer this question on your own. I hope you're done. Okay, let's move on to the solution. It is given in the question that let P be a singly linked list. I'm assuming here that this is a singly linked list and P is the pointer to the first node of the singly linked list. Now let me tell you what is the meaning of P be a singly linked list. Actually, this question is saying P is the pointer to some singly linked list, because P is the representative of this singly linked list. Also, this question is saying let Q be the pointer to an intermediate node X in the list. So I'm assuming here that this is the intermediate node X and Q is the pointer to this particular node. This is my assumption. It could be any other node. It is possible that the intermediate node that we are talking about is this particular node, or it may be this node, or it may be this node. That depends. Now, what is the worst case time complexity of the best known algorithm to delete the node X from the list? Our target is to delete this particular node, and we have to find out the worst case time complexity of the best known algorithm to delete this node. There are multiple ways to delete this node X. The first way is to traverse the list until the node just before the node you want to delete is reached. So traverse the list until the node just before the node you want to delete is reached. That means this node is reached. After reaching this node, it is easy to delete this node. I'm assuming here that this is the data part of the node and this is the link part. Here we have to update the link parts so that this node will point to this node, and then after that we can simply delete this node using free function. That is a very simple procedure, right? But here the time complexity is order of n. You may say that this is the correct option because this is the best known algorithm in my opinion. But no, please wait. Order of n is not the worst case time complexity of the best known algorithm. This is one such algorithm which takes order of n time. Please note that it is possible that intermediate node we are talking about is this particular node. Then obviously order of n will be the worst case time complexity. So definitely wave 1 takes order of n time. As I am assuming here this is the worst case time complexity. It might be possible that this is the intermediate node, then obviously it will take constant time, right? But I'm talking about the worst case time complexity. Way 2 could be copy the data from the next node to the node to be deleted and delete the next node. And let me tell you that way 2 takes order of 1 time. So D is the correct option, let me tell you. And why? Let's see. According to way 2, what I want to say, I will keep another pointer that is temp, which will point to this particular node. And then what I do, I simply put this data over here. That is, I will replace this 67 by 2 using this line of code. And after this, I will update the link part of this node so that this node will point to this particular node. That is the last node of this singly linked list. We can do this by putting this line of code, that is qlink equal to temp link. And this is how it looks like. After this, we can free this particular node. Isn't that it looks like we have deleted this particular node? This algorithm will take constant amount of time no matter what. But please note that this fast solution will not work when node to be deleted is the last node. Obviously in the question it is asking us to delete the intermediate node of the list. And it is asking us to give the worst case time complexity of the best known algorithm. This fast solution will not work when node to be deleted is the last node of the list. This is for sure. But if it is any other node, then surely we can delete that node without any problem. So option D is the correct option for this particular question.